Hello everybody! In this lesson, I will help you with your June exam preparation. I will discuss question 6 of the 2021 paper. The CAPS document tells us that trigonometry counts more or less 27% of your paper. This is the question. Pause the video and quickly try the question yourself and then come back to the explanation. Remember, the question counts 15 marks, so it should not take you more than 15 minutes in the exam. 6.1. Given cos alpha minus beta, the compound angle identity is equal to cos alpha cos beta plus sin alpha sin beta. Use the given identity to derive a formula for cos alpha plus beta. Now the only thing we have is the cos alpha minus beta. And then we're going to change this so that it becomes cos alpha minus beta. And the way we do that is we're going to write a minus there and then inside a bracket negative beta. And we didn't really change the sum because a minus times a minus is a plus anyway. And now that we wrote it as a compound angle there, we can use this identity cos alpha cos beta plus sin alpha sin beta. Can you see? And then where does this plus come from? It's because I expanded it like that. And then the alpha is a positive angle. That's not a problem. And now there's your negative beta, negative beta. So in the next step, what happened here is we say the cos of a negative angle is positive the cos of the positive angle. Can you see? And then there's the plus, there's the plus. And what happened here on sin is we say the sin of a negative angle is negative the sin of the positive angle. And then you just say a plus times a minus is a minus, and then you find a negative inside your identity. And there you did it. Where's the marks for writing that as a cos alpha minus beta, for using the expansion, and then obviously this the final answer, but it's actually where you knew the rules that said the cos of a negative angle and the sin of a negative angle. 6.1.2. Simplify completely 2 cos 6x cos 4x minus cos 10x plus 2 sin squared x. So if you look at this cos 10x, it looks as if it's out of place. But do you agree 10x can be written as 6x plus 4x? So what you can do is you can turn this cos 10x into a compound angle identity. And there I did it for you. And then, can you see this cos 6x plus 4x, the compound angle identity? It's this one, cos alpha plus beta. This is from the formula sheet here on the right hand side. So you can, in the place of cos 6x plus 4x, expand it. And just remember that you have to have a minus and then bracket, and then there's your expansion. So in the next step, I'm going to multiply in this minus to get rid of the brackets. And then what happened here was I got rid of the brackets. And now if you look at this one carefully, this is 2 cos 6x cos 4x minus cos 6x cos 4x. This is like having 2ab minus AB, and 2AB minus AB is just AB, and that's what happened. I subtracted them because they were like terms. Then suddenly, can you recognize the compound angle there? Cos, cos, sin, sin with a plus in between, and it's this one. Cos, cos, sin, sin with a plus in between. So this whole thing can be written as cos alpha minus beta. So this thing can be written as cos 6x minus 4x. And then 6x minus 4x is just 2x. And suddenly you find yourself a double angle for cos. And then here on the right hand side from the formula sheet, there's your three options. So which option to choose? My advice to you is to choose the one that contains the sin, since there's a sin squared inside your sum. So that 1 minus 2 sin squared x, that is your double angle. And then minus 2 sin squared x plus 2 sin squared x, they cancel each other out, and the answer is 1. And then where's your 5 marks? For writing the cos 6x plus 4x, there's cos 10x there, and then the expansion of the compound angle identity for reducing it to 6x minus 4x, for giving me the rule for the double angle, and final answer. (6.2) To determine the general solution of tan x is equal to 2 sin 2x where cos x is smaller than 0. So tan x, the quotient identity is tan x is sin over cos. And then also there on sin 2x, that's the double angle. And there's one solution, 2 sin x cos x. And then in the next step, I'm going to multiply in that 2. 2 times 2 is 4. And then here, I want to get rid of the cos x. So I multiply this side by cos x and this side by cos x. And it turns into sin x is 4 sin x cos squared, because cos x times cos x is cos squared x. Then I'm getting my little equation in standard form, in other words equal to 0, and I'm going to factorize. I'm going to take out sin x as a common factor. Now that I've got that as factors, I can write it as sin x equals 0, or 4 cos squared x minus 1 is equal to 0. And then for sin x is equal to 0, the answer, the general solution is x is 180 plus k times 360 k element z. And you have to add that because you want the general solution. And then where does the 180 come from? It's easy if I show you using the sin graph there. This point there is 180. So that means all the multiples of 180 will satisfy that equation. And then for the 4 cos squared x minus 1, I'm going to discuss it up there. What you do is you take the negative 1 across and you divide by 4. So I get cos squared x is a quarter. And then to get rid of the square, I take the square root. When I take the square root on the right hand side, I add plus minus. So cos x is plus minus a half. But the question had a restriction where cos x is smaller than 0. That means we are only going to zoom in on the negative. So we will ignore the plus for now. We find the reference angle by saying second function cos a half is equal to 60 degrees. And then what happened here was, if we look at the cast diagram, where is cos negative? Cos is negative in the second and the third quadrant. So the second quadrant is the 180 minus reference angle quadrant. So I get x is 120 plus the k times 360 k element z, because it's general solution. And in the third quadrant, that quadrant is the 180 plus reference angle. So answer, x is 240 plus k times 360 k element z. And where's the marks? The marks are here on the quotient identity. Tan is sin over cos. The double angle for sin 2x, working out x's answer. And then also oh, I missed it, the factors there, and then up here where you take, where you square both sides, and then final answer x is 120 plus k times 360, and x is 240 plus k times 360. On the right-hand side, you will see that I've added the grade 11 and 12 playlists on trigonometry. And on the left-hand side, if you click that video, it will take you to the next question of this 2021 paper.